In addition to being your facilitator today, I'm also the International Project Coordinator for the Global Reading Network. What is the Global Reading Network? Well, we're part of the USAID Leading Through Learning Global Platform, which includes two other global learning networks, the Higher Education Learning Network, or HELEN, and the Education in Crisis and Conflict Network, or ECCN, as well as regional chapters in Latin America and the Caribbean. Our goal is to facilitate the global conversation around foundational skills and education around the world. We hope that in addition to staying tuned to the GRN, you'll be interested in collaboration across the platform with our various networks. We're so glad you've joined us today to exchange your experience, ideas, and enjoy each other's company. Today, we're going to be discussing the science of reading and how it applies to work in foundational skills around the world. We're going to share your experiences working with reading programs, and we're going to get to know one another, share contact information, and most of all, learn from one another. We're going to try to account for what we imagine as a wide range of skills, experience, abilities, and expertise relating to reading research. While we give an overview of the science of reading, we're going to do this to create a baseline for small group networking and discussion. And we'll also be putting links for more information in the chat. There will also be a Q&A option if you have any questions about terminology or information presented today. So what is the science of reading? Well, it's a vast interdisciplinary body of scientifically based research around reading and issues related to reading and writing. This research has been conducted over the last 5 decades across the world, and it's derived from thousands of studies conducted in multiple languages. The U.S. government strategy on international basic education speaks to the systematic improvement of educational systems through evidence-based practices, including focuses on improving learning outcomes across the education continuum, expanding access to quality education for the most marginalized students, and coordinating and leveraging resources to drive results. These 3 objectives can be achieved through clear reading guidance and measurable skills for all students. To take a deeper dive into what research is saying about teaching reading and writing, I'll hand it over to Young-Suk Grace Kim, who will walk us through the National Reading Panel report, 3 theoretical models of reading, and a look at structured pedagogy. Young, over to you.
Thanks, Gary. Hi, everyone. Many of you may be familiar with the National Reading Panel report published in 2000, which played a significant role in the No Child Left Behind initiative in the United States. According to this report, teaching the following skills is crucial for enhancing reading skills: phonemic awareness, phonics, fluency, vocabulary, and comprehension. It is important to note that the findings of the National Reading Panel report are based on a meta-analysis on empirical data available up to the late 1990s, making this evidence rather than a theoretical model. In other words, research data available up until the late 1990s indicated that teaching these 5 skills is essential for improving reading proficiency. Let's turn to theoretical models. The first model that may come to mind is the simple way of reading that was proposed in 1986. According to this model, reading comprehension is determined by 2 primary skills: word reading and language comprehension, or listening comprehension. This model has significantly influenced the field by explicitly recognizing the critical role of word reading in reading comprehension in addition to listening comprehension. In practice, this suggests that both word reading and language comprehension should be developed and taught to support the growth of reading comprehension. However, a limitation of the simple way of reading is that it does not explain what is required to develop these 2 skills. Another prominent theoretical model is the reading rope, published in 2001. According to this model, for word reading, necessary skills include phonological awareness, decoding, and sight word recognition. For language comprehension, essential skills are background knowledge, vocabulary, language structures, verbal reasoning, and literacy knowledge. These strands of skills become increasingly automatic and strategic over time. The reading rope model expands upon the simple way of reading in two ways. First, it specifies the skills needed for both word reading and language comprehension. And second, it suggests that these skills are interwoven. Here's a recent theoretical model called the DEAR, and this was published in 2017. As you can see, DEAR illustrates the component skills of reading as the construction of a house. This analogy is used because reading comprehension is viewed as the highest order skill that's built upon a foundation of other essential skills. In DEAR, the two pillars that support reading comprehension are word reading and listening comprehension, indicating that these skills are necessary for achieving reading comprehension. Positioned directly below reading comprehension is text reading fluency. It serves as a bridge connecting word reading and listening comprehension to reading comprehension. Text reading is reading of connected text, such as sentences and passages, while word reading is reading a single word out of context. For example, the ability to read the word cat is a word reading skill, while reading the cat slept on the windowsill is text reading skill. Text reading is built on word reading, but involves processes and skills beyond word reading. Moving on to the word reading pillar, the foundational skills for word reading include knowledge and awareness of orthography, phonology, and morphology. Orthography encompasses knowledge of letters, such as letter names and sounds, as well as letter patterns like digraphs and other combinations. Phonological awareness involves recognizing and manipulating speech sounds such as syllables and phonemes. Morphological awareness pertains to understanding and recognizing morphological structures within words. For example, the word cats has two smallest units of meaning or morphemes, cat and s for plural. Another example is the word redo, which has two morphemes, re and do. Let's turn to the listening comprehension pillar in there. The skills necessary for listening comprehension include higher order cognitions and regulations, such as making inferences, understanding multiple viewpoints, and monitoring comprehension. These higher order cognitive skills rely on foundational oral language skills, including vocabulary and grammatical and syntactic knowledge. At the very base are domain general cognitive skills or executive functions, such as working memory, inhibitory control, and attentional control. These foundational skills support the learning of all the other skills above them, and that's why it's at the very bottom. There are also two windows within the house structure. The one on the left is social emotional aspects such as attitude, motivation, anxiety, and self-efficacy about reading. These are positioned close to the word reading pillar and text reading skills because social emotional factors closely interact with the development of word reading and text reading skills. The other window on the right side is background knowledge, which includes world cultural knowledge, content knowledge, and discourse knowledge. And this is positioned close to the listening comprehension pillar and beneath text reading because background knowledge develops closely interacting with listening comprehension and text reading. One unique aspect of DEAR is the hierarchical relations hypothesis among the skills and knowledge components. Hierarchical here refers to the fact that skills build on one another. As illustrated in the house figure, reading comprehension is supported by text reading fluency, which in turn is built on word reading and listening comprehension. Word reading relies on the foundational knowledge and awareness of orthography, phonology, and morphology, while listening comprehension depends on higher order cognitive skills and regulation and foundational oral language skills. And all these skills are underpinned by domain general cognitive skills. In practice, hierarchical relations mean that foundational skills need to be taught and developed and cannot be bypassed in order to support the development of higher order cognitive skills, higher order skills such as reading comprehension. An essential aspect of understanding the science of reading is recognizing what it is not. First, it is not a complete body of knowledge. Science continually evolves, and therefore it is crucial to update and refine our understanding based on empirical evidence. Second, the science of reading is not a purchasable product, nor is there a standard curriculum, plan, or program associated with it. Third, the science of reading includes more than just phonics. As you saw in the Deer diagram and others, phonics is only one component of reading instruction. Other skills and knowledge are equally important. Lastly, the science of reading is not confined to a single language or culture. The principles discussed here apply broadly to various languages and writing systems, although some specifics may vary depending on linguistic and orthographic characteristics. In addition to knowing what to teach, how to teach is an important part of the science of reading. Structured literacy is an instructional framework that integrates multiple principles to support student learning. According to a review of literature, structured pedagogy includes the following principles. The first one is maximizing instructional time. According to classroom observation studies, some classrooms maximize their instructional time, whereas other classrooms spend a substantial amount of time on non-instruction related activities. Related to maximizing instructional time is establishing instructional routine. Studies have shown that classrooms where instructional routine is established early in the year spend more time learning and have higher performance in reading at the end of the year. We'll talk about specifics on instructional routine in the next slide. The next principle is systematic and explicit instruction. When teaching target skills, it is important to teach it systematically, considering difficulty of concepts and tasks, and teach them explicitly and directly. Part of systematic and explicit instruction is providing scaffolding. Like a physical scaffolding structure in instruction, scaffolding provides support to complete a task to bridge the student's current status with the instructional goal. Initially, a high level of support is provided, but support is gradually reduced so that eventually students can complete the task independently. And this includes approaches like I do, we do, and you do, where teachers model followed by guided practice and students' independent application of skills. The next important principle is making assessment-informed decisions. There are huge differences among children in their learning needs and their strengths. So high quality instruction starts with assessment to learn about students' strengths and needs and using assessment data to inform instruction. And this topic is a very complex one that deserves another session itself. So we recommend a white paper on formative assessment, and the link is provided here. Last but not least is fostering social and emotional learning and engagement. Best learning occurs when students are socially and emotionally engaged in their learning in the context of supportive relationships. Further details are found in the link again. As stated in the previous slide, establishing instructional routines is important to support maximizing instructional and learning time. According to studies, evidence-based instructional routines as part of structured pedagogy includes the following sequence: a review of previous learning session, presenting new materials connected to the previous learning, providing teacher models, providing opportunities for practice and associated feedback. Conducting regular review of a unit or a segment also facilitates learning. So this was a brief overview of the science of reading, and thank you so much for your attention. Back to you, Carrie.
Thank you so much, Young. Now that we have a brief common understanding of what the science of reading is, what it is not, and how to do it, we can begin to explore how the research of how children learn to read can map onto other important frameworks like the Universal Design for Learning, otherwise known as UDL. This is just one example, but you can think of other examples in programming that you've engaged in. UDL has multiple means of engagement, representation, and expression. You can see how you can map critical components of learning to read, like phonemic awareness, phonics, fluency, vocabulary, and comprehension onto this model. Could you think of multiple ways that a student might express phonemic awareness? One example is my 4-year-old and I go through the grocery store and he can tell me the beginning sound of various items, like B for broccoli. Put any examples you might have in the chat. Another engaging means of expression for vocabulary I have seen is a still life, where a group of 4th graders took vocabulary words from their books and had to freeze act the word. How would you represent the word calculate or disappointment with your body? You can be creative and maybe even have fun in your use of evidence-based practices in literacy education, while still providing multiple access points so that all students are able to access, represent, and express learning to read and write. Now that we've heard of some of the research and theoretical models, we can think about some of the barriers that may exist in our contexts as well. I can imagine that many of you are nodding your heads as you read over this list of how instruction can be complicated by these factors. As we enter our discussion groups, I'm sure this list provides some fodder for your discussion about how best to implement literacy programming in resource-poor environments, including one or many of these challenges. And I'm sure you can also think of more challenges than we have outlined here. We've provided these questions for our small group discussion. And they will be available in the chat so that you can take them with you. It looks like one is missing, so we'll make sure that you get that. Oh, there we go. There it is. Have you seen the science of reading work in your context? How have you used these practices? What more research do you want to see being done? And how do you see the science of reading overlapping with Universal Design for Learning or other initiatives? And now we can't wait to hear more from you.